Thank you for joining us today. My name is Mary Gannon. I'm Senior Editor here at Design World, and we're glad that you're able to join us for the webinar, How to Create Robust Guided Motion for Any Environment. We thank our sponsor, BishopWise Carver Group, today, and wanted to let you know before we start that this webinar will be available afterwards in the archive at www.designworldonline.com and via email. There will be a Q&A at the end of the presentation, so please stick around if you have any questions. And if you're on social media, please feel free to talk about this with the hashtag DWWebinar. Again, my name is Mary Gannon. I'm Senior Editor for Design World, and I'd like to introduce you to Brian Burke, your presenter today. Brian is Product Manager at BishopWise Carver Group. He's passionate about product development and manufacturing with an educational background in computer-aided drafting and design and manufacturing technology. He has more than 10 years of experience in the automation industry with extensive knowledge from the production floor operations to product marketing activities, including CNC machining, lean manufacturing, equipment acquisition and implementation, product literature and catalog development, trade show and expositions. Brian recently became a Six Sigma Black Belt. And I'm going to turn it over to Brian now, and he's going to get started with his presentation.
Thank you very much for the introduction, Mary, and welcome to the webinar presentation. Today we're going to talk about how to create robust guided motion for any environment. And we'll be looking specifically at the BishopWise Carver Dual V product line. First, my background here, been with BishopWise Carver since 2003, came from the manufacturing side with CNC programming and production of all of our products from the component level through assembly. And you can reach out to me on Twitter and on LinkedIn if you would like, and connect with me. That would be wonderful. Okay, so let's take a look here. Dual V is a product of BishopWise Carver Group, and we have quite a range of products and a few sub-companies under us. We have BDM and WRW. BWC is the OEM product group where we make the linear and rotary motion products. BDM is a job shop service type company, and WRW does control systems and system integration work. Dual V, linear components, is a product line of individual parts and pieces. So today we're going to talk about all those pieces and parts, and we'll give you an idea about how to do the sizing calculations for the load and a life estimate. We'll look at some application examples interspersed as we go to keep it entertaining. And we have a very new product addition, vacuum wheels. It extends our range of product offering into the very challenging vacuum applications. Okay, so if you aren't familiar, BishopWise Carver is a WeBank certified woman-owned company, and we work with manufacturers to engineer and build linear and rotary motion solutions, custom complex assemblies, and optimal embedded intelligence systems. We've been in business for over 60 years, and with over 20,000 unique clients, we continue to be a single source of service for accelerated time to market, custom designs, and increased efficiencies. As I mentioned before, Black Diamond is a wholly owned subsidiary of BishopWise Carver, and as a contract manufacturer, we do print to machining, transition to manufacturing, sub-assemblies, and specialty manufacturing, including heat treating. With WRW Engineering, we do embedded intelligence systems, electronic and industrial controls, including motor and control system integrations, and project management from an initial product design up through prototypes and then build. Okay, but BishopWise Carver is the OEM product solutions with components, manual linear guides, and driven actuator systems. We were founded by American toolmaker Bud Wise Carver in 1950, and we're located in the San Francisco Bay Area, and we're a certified green Bay Area green business, means we use very low energy and limited amounts of paper and resources. We're the market leader in guide wheel technology, and we're committed to excellence. Product quality and product performance is top of the list of what we strive to achieve, as well as customer service and support and on-time delivery. We also have global support through our partners with HEPCO through distribution in the UK. Our guided motion offering is limited only by your imagination, and we have in-house application engineers, machining support, and design engineering support for you. We also have full 3D CAD and CAD drawings available for download for your projects. And we have customer service in-house more than 10 hours a day at the toll-free number here you see at the bottom. And if you need engineering assistance with sizing or life calculations or even product recommendations, maybe you have another product that's failing, have some issues, you're welcome to call and we'll give you some expert advice. Okay, BishopWise Carver products in general, a broad overview. We make manual and actuated linear guide systems based on guide wheel and track components. We also do precision ring components and systems, and those can be driven or undriven. And we use a variety of drive types, including belt, chain, lead screw, and ball screw, in a variety of different materials, carbon steel, stainless steel, and various polymers. In the component side, they're very easy to understand and easy to install, very easy to adjust. They can be adjusted in the future on the factory floor on installed equipment. They have very smooth and quiet, low friction motion, and a self-cleaning design usable in all environments. You can see in the picture here, harsh environments is not a problem for our products. Very heavy-duty load applications for durability and long life, and available in a variety of materials. We also do manual guides where instead of components, they are sub-assemblies. So it's a linear guide and the bearings pre-assembled. And they have some of the same characteristics, easy to install, easy to assemble, with load capacities up to 4,000 pounds. In the actuated linear guides, we add the drive mechanism, and we add belts, roller chains, ball screws, or lead screws. And those are typically down the inside of the track channel. And these are available for every environment from clean room to extra dirty, from oven to freezer. In rotary motion, we do power transmission via manual methods, belts, and gear teeth with rack and pinions. We can make rings up to 1.8 meters in diameter out of a single piece of material and unlimited diameters out of multiple pieces of material joining them together. They're precision ground on the running and mounting surfaces for high accuracy. So you can see a typical map of applications on the left-hand side going from components where there's guide wheels and tracks. In the middle, the sub-assemblies, what we call manual linear guides, where there's a track channel, a wheel plate with the wheels pre-assembled, undriven. And then on the right-hand side, you can see we go up to full systems, XYZ gantry systems that are driven with belts, lead screws, or ball screws. On the lower portion, you see the same idea. We do rings and bearings in components, which can be added to your own systems, all the way on the right-hand side up to full driven systems, ring and track systems. We service many markets and applications, so our products are widely accepted, including aerospace and conveyor systems. Some of our biggest applications are in packaging equipment, such as corrugate and cardboard, but you also see a lot of XY gantry systems, textile equipment, and material handling like palletizing and high-frequency packaging. So let's take a look at Dual V motion technology. It's one of our core product lines, and it's based on components. So you can see on the right-hand side some of the pieces and parts. It's linear guide bearings, tracks, and support equipment. We'll take a look at each piece individually. But these products are easy to understand. It's a bearing with a special outside diameter V, double V guide wheel, and it has ground mounting surfaces on the guide wheel, but you can run it on other surfaces. They don't need to be ground, and it's ideal for very long travel lengths in harsh environments and wide temperature ranges. We have temperature ranging from negative 94 degrees Fahrenheit up to 500 degrees Fahrenheit. In its core, it's a double row angular contact ball bearing, and it's heat treated. It's hardened up to 53 Rockwell minimum, and it's available in stainless steel and carbon steel. In the stainless steel, it's 420 stainless, available up to 40 Rockwell, so it's a little less hard there. It's developed out of frustration with recirculating ball bearing design, and the problem with those, we'll look at that in a second, but the bearings the balls themselves can attract debris, leading to failure. So with our design here, the balls are sealed on the inside, and that keeps contaminants out. The self-cleaning design is based off of the wheel rolling on the track surface, and it can handle up to 5.5 meters per second with very high accelerations. The main application for this is in really long lengths and for high accuracy and repeatability. On our components, we have a 3-year limited warranty on our Swiss bearings and a 1-year warranty on all of our other products. Okay, so harsh environments. The 90-degree design of the wheel results in a constant sweeping action that clears debris away from the track. It's suitable for use in the presence of metal chips and powders, fibers, slurries, or sawdust. And we recommend using wheel covers or lubricators in the design to help clear away some of that debris to make it a little less harsh, and also apply lubrication, and that's key. We'll get into that in a minute. But the self-sweeping action to describe is if you take one revolution of the guide wheel, because it's different diameters, at the inner part of the V, it's a smaller diameter, and at the edge of the wheel, it's a larger diameter. So when you have one revolution, the outer edge of the wheel is moving a little bit faster than the inner edge, and that causes a constant sweeping action from the tip of the V to the edge of the V. Okay, so these wheels are available in many different versions and different sizes, and they're meant for specific applications. So we have a size 0 wheel, which is our smallest, all the way up through a 4XL, which is our largest wheel. The 4XL wheel has a capacity of around 3,400 pounds per bearing. And they're available in 2 primary materials, 52100 carbon steel and 440C stainless steel. We use 440C stainless because it's heat treatable, it can be hardened, and it lasts a lot longer for durability. We have a high temperature version and a low temperature version based on the grease and internal components, and a clean room version. It has special Krytox grease in it, and a washdown version for food and other washdown applications. We also have vacuum wheels now available. It's our newest product. So let's compare guide wheels to some of the other technologies available on the market. You'll see on the right-hand side, round rail with recirculating balls, square rail with recirculating balls, and round rail with bushings, like a Teflon bushing. We've rated them from 1 is worst and 5 to best, so they're rank ordered with the preferences there. And you can see the Teflon bushing is the worst in high temperatures and very dirty environments. And where the guide wheels really excel is at high speed, elevated temperatures, and long lengths. Long lengths is one of the largest benefits of dual V guide wheels. It's easy to add additional track length and extend the length, well beyond 20 feet. Whereas if you're using another technology, maybe square rail is listed as a number 2 for poor. It's very difficult to mount guide square rails together in longer lengths. And also guide wheels are rotary capable. You can use them on rotary applications. So to compare them directly, what are some of the disadvantages of round rail? They're incapable of really high speeds, and they're difficult to mount to flat surfaces. They can be very noisy because of the balls as they change direction and recirculate. It causes some noise there. And they're only available in limited lengths of a round rail, typically up to what they can centerless grind, usually like 8 feet long. Profile rail is also has some disadvantages. It requires precision ground surfaces and a lot of time to mount. The contaminants can gather on the rail, get into the balls, and jam the races. In the failure mode, typically the plastic end caps will bust out and the balls will fall off and the machine will come to a stop. And they're also very noisy at high speeds. One of the other disadvantages is there's no adjustable preload. You get a bearing block for a square rail, there's no adjustment, and if there's any wear over time, there's not a lot you can do to compensate for that. So dual V at its core is based on guide wheels, linear guide track, and different methods for mounting the wheels. You can see bushings and journals, and there's two different kinds, concentric and eccentric. We'll get into that in a minute, but both versions of the wheel and track have 90-degree running surfaces available in carbon steel and stainless steel, and hardened or as drawn, which is what we call soft. And then on the track, it can have mounting holes already drilled or undrilled. You can drill them yourself, and they come from the factory, cut to length and polished and ready to be mounted on your machine or equipment. So the wheel itself, I mentioned earlier, there's several different sizes from 0 up to 4XL. We'll take a look at sizing in a little bit for your application. And actually we looked at some of these as well. They come in a sealed shield configuration. A steel shield with a rubber NBR seal is available in sizes 2, 3, and 4, and that's a hybrid technology. Typically in a bearing you'll see either a steel shield or a rubber seal. In our case, on our products 2, 3, and 4, we have a hybrid. It's best of both worlds. There's a chart in our new product catalog showing the different applications and some of the materials and temperature specifications. So if you needed a high temperature wheel, you would look at the chart here. You can see at the lower corner the SS227 wheel is high temperature capable up to 500 degrees, and our SS300 is capable down to the negative 94 degrees. This should help you identify a product in your range for your application. We have some sample applications listed down the middle, but in general, most applications at the top there would work just fine for general purpose factory floor conditions, using like the W1X, the W2X wheel, and they're available in all the different sizes, typically with the seal shield combination. If you look at the dimensions, they're also available in the product catalog. They have a precision bore for mounting, and that's used for accuracy with tight tolerance. The bushings and journals that would mount through there are sized appropriately, so you would not have to worry about calculating your own tolerances. But this would give you a footprint idea of the outside diameter and the width of the bearing itself, as well as the mass. If you have a moving mass, such as on a motion system, you need to calculate your total mass in order to calculate your loads. So here, each component, you can do a quick determination if it might fit within your application. Most of those wheels have holes in them, and you can't mount it directly to a plate or else it will rub. So we have provisions for mounting the guide wheels in the bushings. You can affix the guide wheel to a mounting surface in a precise fashion, and they're all manufactured out of 303 stainless steel in two different versions, a concentric and an eccentric version. The concentric version has the round flange and the hole drilled in the center. That wheel is not adjustable. It will be fixed, and we use those as the main load-carrying guide wheel. The eccentric has an off-center hole and can be adjusted with the hex flange. You can adjust the preload of the guide wheel to the rail using the eccentric wheel, and we prefer not to have load on those, as you could lose some of the adjustment if you put heavy loads against the eccentric cam. They're available in a couple different versions. A standard height profile, which you would see at the right side, has a fairly thick flange, and a low profile head height. You can see in the picture in the middle for very compact assembly instances. They're available in inch and metric versions as well. The other way to mount it would be with a journal. If I could back up just 1 second on that slide, the way that you would mount that would be the wheel would go on the bushing, and a bolt with a washer would go through that hole into a threaded plate or a threaded machine member. So that's one of the ways that you would mount it on a bushing. Whereas if you were to use a journal is another method for mounting. The journal itself has the fasteners integrated into a single piece. So on the image there, the wheel would mount on the left-hand side, and these are available from the factory with the appropriate washer and nut. And so you would simply attach that wheel and you can do the adjustment. There's no need for an additional fastener. One of the unique features is that it enables eccentric adjustment from the opposite side of a mounting surface, and that could be maybe behind a large machine plate or frame where access to the wheel itself is prohibitive. There's a little arrow you can see kind of at the center on the left, and that indicates the direction of the eccentric. On a concentric version, there isn't an arrow and those wheels are not adjustable. We also have guide wheels with studded threads already attached, and these are swaged studded assemblies, and we make a variety of different studs that attach to the guide wheels, and the materials are all 303 stainless steel, and of course in the same concentric and eccentric versions. We can mount any of the guide wheels that you saw, maybe the high temperature or the low temperature wheel, to a stud in sizes 0 through 4, carbon or stainless steel. So any one of those wheels can be studded. But in general, the standard general purpose stainless version and the general purpose carbon steel version are available readily in the studded version. We have a couple series of studded versions. The standard is the SWI Series for the studded wheel. You can see at the top. And it's a compact stud and for low assembly heights. And we actually use this product in our Utilitrack carriage assemblies and some of our other product lines, but it's very popular as an individual component. You won't need a fastener. You can simply mount the concentric into a threaded hole, or you can mount the eccentric into a reamed pilot hole with a counterborer and then the nut that goes on top. So it's very simple. You don't need to order other bolts. The SWI Series is a studded wheel assembly series, and it has a longer threaded section, and it can be used to mount in thicker plates if you have thicker requirements, and it comes with the washer and the nut already assembled. We also have polymer wheels that I haven't talked about yet, and you can see here that's the SWI Series polymer overmolded wheels. They're available in the smaller sizes, 0, 1, and 2. They are not intended for very heavy loads. They're meant for light-duty, light loads. And it's a stainless bearing with a polymer overmold, and it's a single row ball bearing that's shielded. It's not a double row, so it's meant for lighter duty applications, and it's smooth and very quiet. This is one of our most quiet products, and it can be run on aluminum extrusions with hard anodize. You can see on the right-hand side we have our Utilitrack V profile, but these plastic wheels can be mounted on equipment or directly as components. Because the head heights to the hexes are fairly low, we have custom thin wrenches for making the adjustments. These are used during installation or adjustment of the eccentric, and they work with the studded wheels, bushings, and journals. They're made out of a good quality steel, 4310 steel that's heat treated, and it's black oxide coating to reduce corrosion. They're available for every size of the product, 0 through 4. The largest size, 4XL, can accommodate a standard wrench, so you wouldn't need a wrench for that. And they're double-ended. The M is for the metric version, and the I is for the inch version. So one wrench you can use to assemble multiple products. The guide wheels would run down the track, and here you can see it's a single-edge track. It's very easy to install. The mounting shoulder allows for accurate positioning of the V-ways, and you can use simple hand tools and common fasteners, simple bolts and Allen wrenches to mount the track down. It's available as formed, which is the soft version, or induction hardened, and both versions are polished on the running surfaces. You can get it with or without holes, and you can also get it threaded. We do many different custom versions, but standard lengths are available in the catalog, but typically they are cut and drilled to a machine's specification or a customer specification. They're available in stainless steel. On the track, it's 420 stainless, and on the carbon, it's 1045 carbon steel. The maximum length of a single piece is 20 feet hardened and 22 feet soft, but you can butt join them for unlimited lengths. You can attach multiple pieces and make very, very long lengths. Hi, I mentioned about, ooh, we had a slide, go ahead there. I mentioned that the material's there, 420 stainless, and it's up to 40 Rockwell, and the carbon steel 1045 is 53 Rockwell. The standard lengths in the catalog ship directly from inventory in our warehouse, and the custom lengths are drilled and made to order on very short lead times. It's typical to get less than a 2-week lead time, perhaps a 1-week lead time on custom drilling. And we also do finishing operations. You can get plating, electroless nickel, thin dense chrome, black oxide, or even paint, so that you wouldn't have to do those applications when you receive the product. You can order that from the factory complete. So one of the things that's really important for the life of a linear guide system is the presence of lubrication. And we have a lubricator assembly which comes with mounting screws and washers. And these wipe debris from the V-guide track, and it continually dispenses lubricant. The lubricant reduces friction and reduces wear and also inhibits corrosion while increasing the system life. We have different versions, a standard height and a low profile version to match the bushings and also match the journals. So if you have an assembly over a plate and you know the V height, there's a lubricator meant just to go with that. And the kit comes with all the necessary parts. It comes with the stainless steel housing to hold the felt. It includes the felt, all the mounting screws and washers, and the bottle of lubricant to get you started. Another version is a wheel cover, which actually goes all the way around the wheel. And this reduces pinch points, and it protects the wheel track interface. There's actually two foam, I said foams, but they're felts. There's two felts, one on either side of the wheel. So it will wipe material away from the wheel as it moves in either direction. They're also available in standard heights and low profile height configurations, and they would work for the studded wheels as well as the bushing wheels. And they include all of the necessary parts. So when you're thinking about using the guide wheel, the number one thing is going to be the capacity. Will it be appropriately capable of carrying my load? The second question you're going to ask is, how long is that going to last carrying that load? So we're going to look at some of the capacities here. These are the recommended capacities. To do the sizing and life estimate, it's 3 simple steps. You calculate the load on each bearing in the system using typically a free body diagram. You calculate the load factor for the most heavily loaded wheel, and then you calculate the life estimate using the equation provided. All of the calculations in the table are based off of empirical data used in general applications, and you'll see that a wheel is routinely able to achieve travel lives of 1 million cycles or higher when you stay within the specified load capacities. So there's several things that contribute to the load life. The size of the bearing, of course. If you do the calculation and you're not happy with the life, you can go to the next larger size bearing and you would get longer life. Also the spacing of the wheels, that would change the free body diagram, would cause the wheel maybe to be less loaded or share the load amongst other wheels. The velocity and the acceleration, the speeds at which you're using it, will affect the life, shock and vibration, and of course temperature. Many different things to consider when you're looking at life. So step one, calculate the loads on each bearing in the system. In the bubbles, we have 3 different scenarios. Simple free body diagram showing guide wheels and track mounted in the system. F is the force or the load. Maybe you have a saw that you've attached to this carriage and you want to move it. So for this calculation, we're going to assume scenario 3 at the top right-hand corner, where there's a mass X distance away from the V's of the guide wheels, and it's 200 pounds at 15 inches away, and the spacing of the tracks is 5 inches. So you can see that we've calculated it down. You need to calculate in all directions, all required directions, to find the most heavily loaded direction. In this case, we calculate out 100 pounds per guide wheel. Step 2, calculate the load factor, LF, for the most heavily loaded bearing. So we're going to continue this example, but we're going to use the W4X guide wheel and from the chart. So when you calculate that out, it's essentially a ratio. You take the total capacity on the bottom of the ratio and you put the calculated load on the top of the ratio. And here we're coming out with 0.38 for the load factor. Step 3, calculate the estimate by applying the load factor to the load life equation. And we have the equation here at the top where we have the LF is a load factor. LC is a life constant, and we have another chart here. And the life constant is based on inches of travel. And for comparison, if you'd like metric units, we also have kilometers of travel life. And then AF is an adjustment factor. You can see we multiply that at the end. That's a D rating. And the application conditions to cause that might include contamination, high duty cycle, high speed, high acceleration, high shock, things like that. So if you're in the high range, you want to use an adjustment factor of 0.1 to 0.4, somewhere in that range. But if it's very clean, there's not a lot of shock, it's very smooth motion, then you could go all the way down to a 1, which is no adjustment factor. The typical applications are going to be in the 0.5 to 0.8 range of adjustment factor. So for our application here at the bottom, you can see we've calculated out a life of that system using the W4X wheel. It came out to 124.7 times 10 to the 6th inches of travel. So what you need to do once you get to this point is to determine how long will it take in your application before that life is used up, and are you okay with that? If you're moving very fast 24/7, you might be able to achieve that within a few weeks. So if you're moving very infrequently, you could calculate that out. Could be up to 10 years of life perhaps. So let's look at some applications too. Here's a pipe cutting application and beveling. A torch is guided on dual V, and it's meant to be attached to a pipe in the field to prepare pipes for welding. You can see that there's a main frame and some other gears and other machine parts, but this torch will then turn and rotate around the pipe, causing a bevel flange, and that allows welders to attach pipes in the field. It's all easily and simply attached to metal pieces using common fasteners, bolts, and screws. Another application, which also happens to be welding equipment, is a multi-axis automated machine that does welding, and it will do the oscillations to create a continuous weld pool. And you can see it's a 2-axis machine based on dual V guide wheels, track, and bushings. And if you look on the right-hand side, you can see the track is mounted with some hex head bolts and washers to a machine frame. In this case, the machine frame is machined out of a piece of steel, and the track is attached to it. And the guide wheels are used to make up 2 axes of motion. A really common application for our products is in packaging equipment. And in this case is a shrink wrapping application. The machine takes products and it pushes it through a roll of plastic film, and then it goes through a shrink tunnel to do the shrinking. And there's many axes of motion within a packaging or shrink wrapping machine. So let's take a look at a few based on dual V. In this case, if you zoom in to the sections of the machine, you can see that dual V is good in really long applications. On the picture on the top right-hand side, I call those the pusher axis. Typically, the material does not move through these machines in a straight line. They move in like a U-type direction, and they require pushes in different directions to get through the machine. And in this case, it's using size 3 guide wheels mounted on journals, and the pusher axis there is about 5 feet. So as the product comes through the machine, it collects in that section, and then it will push it 5 feet. On the right-hand corner in the bottom, you can see that this customer was using a square profile rail below a pneumatic cylinder to do pushing, but they've also designed another system using the dual V guide wheels mounted on track and pushing it also with an air cylinder. So they're experimenting with both versions and having great success with the dual V guide wheels. Typically, you can see in a machine like this, the adoption of dual V guide wheels is that it's applied to many different axes within the machine once the customer is comfortable with it. Here's another dual V application, which is the main components used in our low pro belt-driven actuators, and it's a lumber sawmill application. We manufacture the units shown here on their side, and what this machine is doing, it's picking up long pieces of lumber, loading it onto the conveyor, and there's a saw at the end, which is obscured by the image here, and it's cutting this lumber to specified lengths, all automated. So here is automated material handling based on dual V guide wheels in a lumber environment. So there's a presence of sawdust and other factory debris. One other application here is food processing equipment. I mentioned a washdown wheel that we have. And this is a high cycle melon cutting machine that travels 180,000 inches every day. And it's subject to washdown environments, and it needs to be food grade. And in this case, the washdown wheels are mounted on a stainless steel frame that was welded, and there's a motor driving a blade. And so that guillotine blade goes up and down, slicing the melon as it's fed through the machine. If you look on the lower right-hand corner, you'll see some of the dual V guide track also mounted with hex head bolts. So one of the newest products from BishopWise Carver is the vacuum wheel. The vacuum wheels are the identical shape and quality as other dual V guide wheels, available in the smaller sizes, size 1 and size 2. And it's an all stainless design, including the ball cages on the inside are 304 stainless. And we use a special ultra-high vacuum grease, which is Ultratherm 2000. And it's capable of reaching vacuums of 10 to the minus 9th millibars, which is a very low vacuum considered ultra-high vacuum. And it's also compatible with the standard 303 stainless bushings and 420 stainless track. If you can see here some of the materials that we use in there, it's all stainless construction and grease. The grease is capable of withstanding temperature. In most cases on a bearing, the grease is a limiting factor for the temperature ranges, usually not the materials. In some cases you will get to an elevated temperature and melt the rubber, the NBR seal. But in this case the grease can handle up to 250 degrees C intermittently, or up to 150 degrees C continuously in a vacuum chamber environment. The grease itself, of course, has a curve of temperature versus vapor pressure, and it's very low outgassing as well. So it's up to the design engineer of the test equipment or the vacuum chamber themselves to determine suitability, and we provide the specification sheet from the grease manufacturer directly. So yes, in this case, the customers to determine suitability, all the materials are known, and BWC is not independently verified materials in all applications. The specifications are based upon the material properties. And of course, lubrication is always recommended. In vacuum environments, there's usually a hesitation to apply lubrication, but it reduces friction, reduces wear, extends life. So we recommend using vacuum grease whenever possible. And of course, to use these wheels, it follows the same three-step calculation for the load and life calculation. Some of the vacuum environments that you might see would be in high technology, like research and development or material science, in semiconductor or electronics fabrications. But you'll also see high altitude testing and simulation, maybe like a space environment simulation at NASA's labs. And other applications might include life sciences or pharmaceutical processing. You can do filling, encapsulating, or dosing. You can also do degassing. So maybe you're curing epoxies within a vacuum so that there are no bubbles. And also packaging, sealing, and leak testing. Those are done in vacuum environments as well as other material science applications. So when you take a look at applications, our wheel is down to 10 to the minus 9th millibars, and we cover most applications, but not as many. There's some higher vacuums applications, but in general, we would cover probably 80 to 90% of the vacuum applications. So where would this be used in a vacuum environment? Typically on sliding equipment racks for loading and unloading other devices into and out of a vacuum chamber, or in automated material handling and manipulation devices, perhaps a transfer system or a load lock system. So on a sliding equipment rack, here's an example, a space simulation and testing chamber. Typically in a vacuum chamber, a product or package to be tested would be wheeled in on a cart like you can see on the right-hand side. But in some cases, and with Dual V, you can now build a permanent rack inside the chamber that will slide out for easier loading and mounting. And a load lock application. A load lock is a device used to put a single substrate into a process tool or chamber, and typically an operator would open the lid, manually insert a wafer or a substrate, close the lid, pump down the vacuum to the appropriate vacuum, and then open the door and allow the product to be inserted into the tool for processing. So these applications can be highly automated, requiring linear motion within vacuum environments. Okay, so in summary, Dual V linear guide components, they're ideal for many applications. They're easy to understand, easy to assemble, and very easy to adjust. They're component-based, so that you can purchase only what you need and integrate them into your equipment. You can download the 3D CAD models from the website and include it in your designs. And they're also field adjustable as far as eccentricity of wheel preload and mounting to the track. They're ideal for long length systems. If you have something that's maybe 8 feet long all the way up to 40 feet long, it's not a problem with Dual V guide wheels and track. They're great in harsh and debris-laden environments such as sawdust and metal chips, but they can also be used in clean rooms, washdown environments, and vacuum chamber environments, so quite a wide range of applications. And they have high load capacities and custom installation heights with the different bushings. Okay, so I thank you for your attention during the presentation. I would like to open it up to if there's any questions about Dual V guide wheels used in any environment.
Thank you, Brian. That was very interesting and very informative. We do have a couple questions. A lot of them are kind of application specific. We do have one wondering if you have any experience using these in heavy-duty applications such as rock grinders.
Yes, there are applications used in rock grinders and concrete fabrication. One of my earlier pictures was actually a water jet cutting concrete boards, some concrete boards, and the wheel there can handle that. What we do recommend definitely is diligent maintenance. As with anything, if you have really heavy contamination, you want to design some type of shield or guard to keep the majority of it out of there. Out of that interface. But in general, our products work very well within heavy contamination. I've seen applications as well using like ceramics and processing ceramics, and the ceramic dust itself can land on the guide wheel and track, and it can tolerate that as well.
Great. Another one about the equipment, wondering if it was made from aluminum and how much does it weigh?
The aluminum, there's a lot of different products, and in the catalogs we have the masses, and so you would basically add up what the masses are, and the weight of that track itself. I believe you're referring to the Utilitrack aluminum with the plastic wheels that I talked about. That number is available in the catalog. There's actually 3 different sizes of those aluminum extrusions. There's a 0, a 1, and a 2. And then there's actually a V profile and a roller profile, which is an open channel. So please see our Utilitrack catalog for that information.
And regarding the vacuum components, somebody wants to know what the vacuum is rated to, up to.
Yeah, on that first slide, I mentioned the millibar rating. Let me pull that up real quickly here. Yeah, it's rated to 10 to the minus 9th millibar. That's 1 times 10 to the minus 9th millibar. And in torrs, that's 7.5 times 10 to the negative 10th torr. and that's dependent upon the grease and the temperature range. So you can get to that vacuum rating only at specified temperatures. So you definitely want to check the spec sheet of that chart and make sure that the application you have in mind is within the vacuum specification.
Great. And another application question, wondering if there's going to be a future for a submersible high-temperature dual V bearing for hot water industrial washers. Do you see something like that coming in the future for you guys?
That's not in the specific works, but there may be a solution, and we actually entertain many custom applications. Our washdown wheel came about from a specific application requiring high-pressure washdown, and so we do entertain custom wheels if something would not work. But I definitely encourage you to contact our application engineers and see if there isn't a product in our mix already that would be available for that application.
And another question, kind of, since you brought up the washdown wheel, are they compatible for use? What makes them compatible for use in washdown environments?
I've added a slide at the end of the presentation here. Let's see. So the washdown wheel itself has a double seal design, and the outer seal is flexible under high pressure, and the inner seal is a typical seal like you would normally see, and it's stationary. And so what happens is under high pressure, the outer seal deflects and seals. So if you see the lower left-hand corner, under pressure, the seal deflects and it seals from any ingress of water or other materials, and that allows for longer life. Typically, the life is reduced in a wheel when the grease breaks down or is no longer available, and a high-pressure washdown without very good protection will tend to wash out the grease. And so with this technology here, we get up to 3 times the life under washdown applications.
Great. And our final question is, how is the dual V track mounted?
There's many different ways to mount dual V track, and I have another slide for that one. Typically, you see it has a mounting surface, and it can be attached to a support structure. That support structure can be unmachined if you don't need high accuracy, or you can prep that surface by machining it and mount it down using the reference edge. Typically, you would use a button head cap screw, so that mounting surface would have a threaded hole in it down the length where you want to attach. And we have the standard hole spacings that you could design with. You could also do a flathead screw if you wanted no material above the track itself or low profile. And you can also bottom mount it. So if you have a threaded hole, you can design your base to have a through hole and a counterbore perhaps and thread directly in to attach it. But I've also seen some common applications include welding the track itself to the base without fasteners. So there's quite a few ways that you can attach the track.
There's one more question that just came in, Brian,
Okay.
and it is, what type of precision can you achieve with these components?
The guide track itself will follow the accuracy. It's like a piece of spaghetti. It will follow the accuracy of the mounting surface. So if you do a precision machined mounting surface, you can get accuracies to within 1,000th or 2,000ths. But there's many applications that don't require that level of accuracy. Maybe you have a very heavy load that you want to move to another location, and so the accuracies are typically a little bit lower than you would find in a precision ground profile rail. So there's a trade-off in deciding whether that meets your application requirements or not.
Great. That is now it for the questions now. So thank you so much for presenting, Brian. That was very interesting and informative. And we thank everyone for attending. This webinar will be available at designworldonline.com, and we will also be emailing it out. Again, if you found something interesting, you're welcome to tweet it out with the hashtag DWWebinar, and you can connect with us, Design World, at all of our social media channels that you can see there on the screen. And feel free to discuss this conversation further at engineeringexchange.com. And feel free also, we will give you the contact information for Brian as well if you have further information that you need to contact him, just let us know. Thank you so much, and goodbye.